This is problem 72 of Giancoli 6th edition, chapter 10. So what we have is a simple geological model that considers a continent as a block. And this block is floating in the mantle rock. Okay? And they give us the density of this block, the density of this continent. So I'll call it density of B, density of the block. And they also give us the density of the mantle. So I'll call it density M. And the reason why this block, this continent is floating is of course because the density of this block is less than the density of the mantle. Okay? And they say, assuming that this continent has a certain thickness, estimate the height of the continent that is above the surrounding rock. So the picture that we have in mind is more or less the following. We have here the whole continent, this block. Part of it is submerged in the mantle. Okay, so this is the mantle here. So part of this block is submerged, and the buoyant force is acting on this part that is submerged, and part of it is outside. They gave us the thickness of this block, and the thickness is 35 kilograms. They want to know how much stick out. So they want to know what is this y here, what is this height. Okay, so what we know is that the buoyant force is holding this continent so it doesn't sink. So this means that the buoyant force is equal to the weight of this whole continent. All right, we know that buoyant force is equal to the weight of the fluid, the weight of the mantle that was displaced. So I'm going to write this as weight, and with this I can cancel G. The mass of the mantle they didn't give to us. The mass of the mantle that was displaced so that this continent, this block could fit in, is not given to us. So I'm going to resort to the equation from density. Density was given to us. So density is the mass divided by the volume. So instead of the mass of the mantle, I'm going to write the density of the mantle multiplied by the volume of the mantle that was displaced. Okay, and this is equal to the mass of the block, the mass of the continent. Again, I'm going to use the equation for density and write this mass in terms of the density of the block, which I know, multiplied by the volume of the whole block, the whole continent. Okay? And the question is, how much of this block sticks out? Well, the density of the mantle is known. What is the volume of the mantle that was displaced? The volume of this piece of the mantle, this piece of the block that is inside, is the area multiplied by this height here, okay? This part which is submerged. And what is this part that is submerged? The whole 35, the whole thickness, minus y. Okay, so this is what I'm entering here, 35 minus y. And this is equal to the density of the block, which we know, and the volume of the block. Now, the volume of the block is the whole thing, and so we have here the area is the same, right, multiplied by the whole thing, which is 35. Okay, now the area doesn't matter to us, and here we see it can just be canceled. Everything else in this problem we know. The only thing that we don't know is our unknown, is our y, the height of the continent that sticks out.